Lighting is a great way of adding that little bit extra to your model railway, and in this video I'm going to be adding some to my coaches, so I can show off the 3D printed interior I made in part 1 of my Lima Mk2 makeover. I'll be demonstrating how with fairly standard components and no specialist equipment we can make our own LED lighting strips, how we can get power from the track using some axle pickups for which our Lima wheels are ideally suited, and how we get the AC power from my DCC layout, convert it to direct current, and supply to the LEDs for optimum brightness with the aid of a resistor. And even how we can keep our lights flicker free with the installation of a stay alive capacitor. All a massive upgrade to our coach. So without further ado, let's get started. As with the interior replacement, the first thing we need to do is get inside. And with the old Lima, it's not immediately clear how to do this. But let me demonstrate. The roof and windows are actually one unit, and inside there are a couple of clips holding it in place. Pushing in the two central windows on either side goes some way to releasing these, but the real trick is to give the body a twist, opening up a gap at the end of the roof, where there's another plastic clip. This usually pops out relatively easily, but you may need to prise it open with a blade. Then the whole thing, roof and windows, just lifts out, revealing the clips on the side of the roof unit and the old interior, all of which I'll be removing, to be replaced by my new 3D printed one that I covered in the previous video, although you can still do the lighting with the original. And whatever you choose, here's what we need, starting with some strip board. This is like an all-purpose printed circuit board, with conductive copper strips pre-drilled for components, and it's on this we're going to mount our LEDs, running the length of the coach, spaced at regular intervals. The board itself is relatively easy to get hold of, but you may need to shop around to get a long enough piece. Next up are our LEDs. In the past I've used the standard bulb type, but for this video I'll be using the much smaller surface mounted sort, as even though they're fiddlier to install, they're much neater and more discreet. Then to get the right brightness we'll need some resistors, and of course some way to provide the current. For this I'll be using these pickup springs, to take the power from the track via the axles of the wheels. We'll see exactly how that works a little later on, but essentially we've got a winding of fine wire, designed to fit the diameter of the standard axle for the gauge we're working with. My layout is DCC, which with a constant voltage is ideal for things like coach lighting, but I will need a bridge rectifier to turn AC to DC, and for that I'll be building a little circuit board, again using a bit of our strip board. Finally, to avoid any flicker from dirty track, I'm going to install a capacitor. Again, much more about that later on. All the components are listed out in the description, along with details of the one specialist piece of equipment which will make our life much easier, a back-to-back gauge, to restore the spacing between the wheels once we put the springs on. That's for a later stage, but let's get started by building our lighting strip, for which we're going to need to slice up our strip board into lengths 2 conductors wide, discarding that first metal strip. The board itself is pretty tough, and the gap between the conductors narrow, so very much a job for my razor saw. The only real difficulty being keeping it straight and in between the copper strips. The board is also brittle, so needs supporting for the full length, and I found the easiest way to do this is to use a wooden batten, clamping it to my tabletop, and then moving the clamp from one end to the other as I pass, giving a clear run for the saw. Then with that first strip out of the way, moving our board out by 2 strips, reclamping and going on to the next cut, making sure we stay in the gap. The board is a kind of fiberglass and the dust produced isn't hazardous in the quantities we're producing, but we do want to avoid breathing any in, as it's not very nice, and definitely clean up afterwards. Having made my new 3D printed interior, I'm obviously going to use that, but as mentioned you can use the original, the process being very much the same, but you will need to find a way of supporting the strip. Mine has some cutouts on the bulkheads for this very purpose, and once in place we can mark out the position of the LEDs, starting with the toilets and the vestibule at the end. Then one for each set of seats, corresponding with the windows. A big advantage of making our own over a ready-made strip is we can space the LEDs as we want. It's also considerably cheaper, and the rigid strip needs no other support. We're going to be mounting our LEDs underneath the strip, so once we mark the top we need to mark the sides. But before we go on to fit them, let's have a look at some LEDs. I'm sure we're all familiar with the traditional bulb type, and we could use these, pushing the legs through the holes in the strip and soldering to the copper conductors, but as you can see they're quite bulky, so instead we're going to use this surface mounted sort, which will usually come packaged in a plastic strip, the film being peeled back to release them. The most obvious thing is how small they are, but also the fact they have no legs. Instead, the anode and cathode are shiny metal pads at either end, the cathode being indicated by a little triangular notch in the front, so we know which one is which, cathode at the bottom and anode at the top. And it's these pads, as the name suggests, we're going to solder to the surface of our copper, all the cathodes to one strip and the anodes to the other. Now, surface-mounted components are really designed for a more industrial assembly, but actually very usable with a standard soldering iron. And I'm just going down the length of my strip, laying down a little bit of solder next to each of my marks, keeping it as flat as possible. We don't really want any blobs. In a more commercial setting, this will be done with solder paste, which is melted under the component on a hot plate or in a reflow oven. We don't have either of those, so we're going to have to do it by hand, but even then it doesn't take us long to get to the other end. You'll notice that I've put the solder in between each of the holes. We want to keep those clear, particularly at the end, for some other components. You'll also notice that I've only done one of the strips. Onto this, I'm going to attach my LEDs, starting with the cathodes, the ones marked with the triangular notches. Now for the fiddly bit. We want to get our LED onto our strip, lining it up as straight as possible, and holding it in place while we remelt the solder. I'm showing this in real time so you get some idea of how long it takes. You know it's done when the solder goes silvery and will have flowed underneath the component, making the electrical connection and holding it in place. Then on to the next one, checking for that triangular notch to show the cathode, and lining up on the strip, ready for soldering. It doesn't actually matter if you do cathodes or anodes first, just remember which ones you're doing and make sure they're all the same. If you do get one the wrong way round, just remelt and remove it, switch it round and try again. Then on to number 3, once again checking the cathode. Don't worry, I'm not going to show soldering all of them, I just want to share some tips. First of all, keep them in the packaging until you need them. It's really easy for them to get lost. Also, my tweezers have PPS tips, so my lenses won't get scratched. And while we're on the subject of lenses, ignore that they appear to be yellow. The light is actually a warm white. Next tip is not to worry if they're not perfectly straight, or bang in the middle of the strip. But if they are really wonky, now is the time to adjust them, as it's considerably more difficult once the other side is soldered. And likewise if you've got them the wrong way round. So before we go on to the next stage, just take a moment to check the positions and make sure all of the notches are on this side. Now we can move on to the anodes, and for these I'm feeding the solder in from the side, where it will flow in under the LED. The trick here is to angle the soldering iron tip, so it heats both the copper strip and the electrode, allowing the solder to melt along the width of the joint, creeping underneath. You don't need much, just enough to make the connection, which you can check visually from the side. Doing it like this rather than laying down the solder first, like we did with cathodes, makes it much easier to get our LED flat, not only making a better connection, but also looking neater. And it's quicker, the LED's already being held in place by the other side, so it doesn't take long before our lighting strip is complete, which we can put to one side while we get on with the next stage, which is wiring the pickups on the bogies, and this is made quite a bit easier if we take them out first. Realism-wise, our Lima bogies aren't that great, but they are really easy to work with, the sides flexing easily to remove the wheel sets, a thumbnail strong enough to bend the relatively soft plastic. The wheels too lack authenticity, with their oversized flanges, but with one wheel actually attached to the axle, they're perfect for our pickup springs, for which we need to remove the other wheel to get them on. Long nose pliers ideal for the job, just be careful not to damage the pointy end of the axle, or your fingers on the relatively sharp metal while you pull the wheel off. As you can see, my second-hand coach is really quite grubby, so this is the perfect opportunity to give my wheels a really good clean, and make sure my axle is really shiny, for the best possible electrical connection. For this I'm using some chrome polish, which is less abrasive than Brasso, but we still need to make sure that everything is wiped off, and no residue is left behind. Also, if you prefer a less shiny wheel rim, now is the time to paint them. But for me, it's on with the pickups, and the springs we saw earlier. With the other wheel removed, these simply slip over the axle, providing an electrical connection to the attached wheel, and ultimately to the track on that side. And we'll alternate left, right, to get pickup from both tracks. The fit is loose enough to create virtually no friction, while the multiple coils maintain continuous power. And with all our springs installed, it's time to replace the insulated wheels, a job made much easier with our back-to-back gauge. This is essentially a brass cylinder, the exact width of the ideal distance between the backs of the two wheels, with a slot for the axle, and enough space for our spring, and the plastic insert of the second wheel, which just pushes on, the gauge sliding out to the side. At around about 10 quid, the gauge is a pretty good investment, making short work of all 4 wheel sets, some of which are more stubborn than others. The standard gauge is ideal for the Lima wheels, but they do come in a range of widths, for fine or even extra fine wheel sets. I'll put the DCC Concepts product page in the description, so you can find the one that's right for you. Then with all 4 axles reassembled, we can put them back in the bogies, again just flexing the plastic around the ends. The only thing we need to remember is that our insulated wheel needs to be on the other side, so each bogie has a pickup from both tracks. Depending on the tightness of the fit, it can be quite easy for that insulated wheel to shift on the axle while refitting, but easy to adjust again with our back-to-back gauge, and even if they haven't, it's worth a check. Then on to bogie number 2, refitting those wheel sets in exactly the same way. It doesn't actually matter which axle has the insulated wheel on which side, just as long as they're on the opposites, again getting pickup from both tracks. With my digital system, the power through those pickups is an alternating current. The voltage is constant, which is ideal for my lights, but I do need to change the current to DC, which is where my bridge rectifier comes in. This is essentially a bunch of diodes, encased in a plastic shell, which as luck would have it, fits exactly into the middle of my bogie. It has 4 legs, the longest being the positive of the DC output, with the negative diagonally opposite. The other 2 are for my AC input, which will wire to my pickup springs, so I'm pushing the legs through my little circuit board, so the inputs are on the same diagonal as my springs, leaving the DC positive bottom left and the negative top right. Those legs can now be folded over, holding the rectifier to the back of the board, ready for soldering, although the board is a little bit too long at the moment, so I'll just need to shorten it so it fits neatly. The various connectors are clearly labelled on the top of my rectifier, but that's all going to be hidden, and once I've snipped off the longer leg, I won't know which one is the positive anymore. So a blob of red paint will sort that out, and I can confidently snip off the soldered legs, without losing track of which connector is which. Ready for installation underneath the bogie, our bridge rectifier neatly tucked away, a couple of blobs of superglue holding it in place. Now we want to attach the ends of our pickup springs, soldering them to the copper strips of our mini circuit board. Note that this is really the left-hand wheel, which is attached to the axle, even though it's soldered to the right-hand strip. The right-hand wheel connects to the one diagonally opposite. As the pickup is AC, it doesn't really matter which is which on the single bogie, but we will need to wire like for like when we come to the second one, combining the 2 right-hand pickups and the 2 left ones. Our circuit board here is similar, but much simpler. We don't need another bridge rectifier, so no gaps in the copper strips. And stuck down in a similar way, we can find the ends of our pickup springs, locate them on the outer copper strips, and solder in place. That middle strip is just to get the right width, and doesn't actually do anything. Then it's time to reunite the bogies with the body, as the next step is to wire the 2 sets of pickups together. And being Lima, this couldn't be simpler, just pushing the spindle into the hole. But before we fit the one for the other end, I just need to drill a hole for the wires to go through. We could try and install all the wiring inside the coach, feeding the wires up through the spindles, but this would require quite a lot of modification. So, as with all things Lima, with all their compromises on detail, it's a balance of effort over effect. So I'm going to run my wires between the 2 bogies along the bottom of the chassis. And this is what I'll be using, a fine gauge decoder wire, also from DCC Concepts. Something similar will be just as good, but it does need to be very fine, as we're going to thread it up through the bottom of the bogie and solder onto our copper strip. Anything thicker would interfere with the swivel, possibly not enough to prevent the bogie actually turning, but definitely increasing the risk of derailment. The other end of the wire does the same thing, threads up through the bottom of the bogie, the end soldered to the corresponding copper strip. Just make sure you have indeed got the wheels for the same side joined together, and the bogie swivels freely. Then with a spot of superglue, we can stick down our wire, so it doesn't interfere with the wheels. A drop at either end should be enough, but if there's a lot of slack in your wire, you can always put another one in the middle. So that's the job half done. Both of the right-hand wheels attached to their axles, with the pickup springs joined together on both bogies. Then it's the same for the other side, threading our wire up through the bogie and soldering the end to the other copper strip. Then it's back along under the chassis to the other end. I could have used a different colour for this second wire, but really no need, as with everything clearly visible, it's easy to track them from one end to the other and see which is which. Now, a quick note about clearances. My circuit boards have added a bit to the bottoms of my bogies, not too much to cause any problems, but do watch out for stray wires and keep them as short as possible, or tuck them away to prevent snagging. That's the AC input to the bridge rectifier done. We now need to deal with the DC output, and I'm starting with a grey wire for the negative, soldering a short length to the corresponding strip on our bogie. If you remember, that's the one I didn't mark with red paint. That then needs to be threaded through the frame of the bogie, underneath, avoiding getting tangled in the wheels, and up through the hole we drilled, being careful not to knot or kink the wire, and leaving enough slack so the bogie turns freely. Then a similar thing with the DC positive, an orange wire soldered to the strip marked with the red paint, again threaded through the bogie and up through the hole in the chassis. And that's our pickups done. We've got the blue wires bringing the AC input from the tracks to the bridge rectifier, which switches AC to DC to be supplied to the LEDs, which are picky about polarity via the orange and grey, and it's those we're going to connect to the lighting strip. But we will be needing one of these, a resistor, to reduce the current and get our brightness right. To help with this, I've built myself a little test rig, a simplified version of my components, the bridge rectifier taking the track output direct from the controller, my lighting strip temporarily attached to some jumper cables, so I can easily test the effect of various resistor values, giving a general sense of how bright the lights should be, although the final test will have to be in the coach, as the light will reflect off the interior. But to cut a long story short, this is what I ended up with, a 3000 ohm resistor, and it's that I'm going to connect permanently to my lighting strip, pushing it through the hole I left open, where it can be soldered to the copper of the positive side of my circuit, folding it back over the top of the board so there's no risk of it shorting out with the negative, which I've labelled with a black Sharpie. And having trimmed the legs of the resistor, it's that negative strip we're going to connect up first, soldering the grey wire, which I've shortened and stripped, onto the end of the copper conductor, next door to our first LED. That and my wires are going to go into the end vestibule, so flipping the board over and positioning the LED just beyond the last bulkhead, I can tease my orange wire around and over the top of the strip and solder to the free end of the resistor, making sure I don't melt the plastic. And in its simplest form, that's our lighting complete. My camera makes it look a bit brighter than it really is, especially with the roof off. When that's back on, the purists may argue that's still a bit bright for daylight, but I'm happy. It shows off my interior nicely, and the overall effect demonstrates it's been worth the effort. This next bit is optional. With 2 pickups per rail, we should get a pretty consistent current, but the addition of a capacitor will ensure properly flicker-free lighting. And while it's an extra job, installation isn't difficult. The Mark II coaches have the perfect location, in the corridor behind the toilet, where there's no window. Like many components, our capacitor has 2 legs, the longest being the positive, and both need to be bent and trimmed, so the capacitor fits into that space, the negative pushing through one of the holes in the near side of our lighting strip. That's the one with the cathodes of our LEDs. Temporarily flipping over the strip and clamping for support, we can solder that in place. The legs not only provide the electrical connection, they'll help support our capacitor, and are nice and bendy, making it easy to adjust its position and line up with the other components, the positive folding round alongside the join of the orange wire and the resistor, where it can be soldered, hopefully without disturbing the existing connection. Then snipping off the loose ends, we can refit the lighting strip, lowering our capacitor into the gap, gently bending the wires to adjust the position and make sure they're out of the way for the replacement of the roof. But before that, let's give it a test, making sure everything still works, and seeing our flicker free in action, with enough charge left in the capacitor for our lights to stay on for a good while, even when off the track. Then I've got one last job, lining the roof with insulating tape, bringing it down just a millimetre over the glazing so no light creeps out between the painted roof and the tops of the body sides. Then we can clip it on, and that's our job done. Another Mark II coach, joining my growing fleet of illuminated rolling stock, looking great during the day, and even better at twilight.